Okay, I'm going to get started now, even though I don't think the room monitors shut the door. So today I'm going to talk to you about using machine learning techniques within Alfresco to create recommended content, so a different way of bringing the content to the user. But first, the obligatory slide from my employer. So Ixxus are a leading global provider of custom-built content solutions. And we're a global platinum partner. And personally, I've been working with Alfresco since version 0.6 back in September 2005. And along the way, I've presented at various different conferences. And some of these are particularly relevant. So Apache Lucene Eurocon in Barcelona, I met Grant Ingersoll from LucidWorks, and he's an Apache committer involved in Solar and was one of the founders of the Mahout framework. And consequently, I ended up writing a magazine article for Groovy Mag on using Mahout within Grails. But before we dive into technical details, I thought I'd take you on a little journey. So hopefully most people recognise what that is, and someone can tell me what it is. It is, but in this case, it's a discovery. So we're going to talk about discovering information. So how did we find existing knowledge? How did we find answers 30 years ago? And how was that information organised? So when I grew up, one of the things we had on the shelf, and it wasn't quite that fancy, but we had a set of encyclopedia. So you had this alphabetically indexed content. You'd ripple through it and go, okay, this is everything to know in a paragraph about one subject. But that's the Encyclopedia Britannica, and they stopped printing it 4 years ago. Or you could go to your local library, and of course that's categorised using the Dewey Decimal System. Or go to your bookshop and have slightly different categorisation by broader topics. But generally, all these, those three approaches had the same things in common. They were based around books, which are static and lag behind current research, events, and information. And the landscape changed. So this is a lovely quote from the president of Britannica, the people who published those encyclopedia, and they decided that they even used the term pedestrian for that's how static they felt that the content production cycle had become for them. So back to discoverability, metadata is key. It gives us multiple dimensions through which we can explore and discover information. So how can you currently find information within Alfresco? A quick recap. Unfortunately, the yellow doesn't show up brilliantly, but at the top we've got things like taxonomy. So you've got categories of information. You can navigate through the categories. You can browse. You can traverse association relationships. But there's not many ways of bringing the content to you. Obviously, things like the activities feed or workflow if someone assigns you a document. But otherwise, it generally involves user action. Over the last few years, there have been a number of big trends in IT that have been categorised as SMAC, so social, mobile, analytics, and cloud. And obviously, Alfresco have been busy working along most of those. But in terms of social, there are only a few ways of really interacting socially within Share, but obviously one area that they worked on in the late 3.4 release was the publications channel. So you could actually push out content through publication channels to different things, so push it out to Twitter, etc. But when people talk about social, they often talk about social graph. And in graph theory, one of the classic examples is 6 Degrees of Kevin Bacon. So you can go from Kevin Bacon, find a movie he starred in, and within 6 degrees, in theory, you encompass all of the actors and actresses ever. But we're not really interested in that. So I was going to play a few degrees of John Newton. And last night John was saying, oh yeah, I'm hoping to come along to your talk, but as he hasn't made it, let's start with people who are linked into John. If you can put your hand up. Okay. And if you Oh, there's a few more. And people who work with someone who just, or know someone who just put their hand up, if you can raise your hands as well. So, you know, within a few degrees, we've kind of created a reach effect. So, you know, it doesn't take much before you have influence out through a network. So, if we come back to kind of social content within Alfresco, you know, you can favourite things, again, not implicitly social, but it's more useful as a bookmarking way. Oh, John, I'll have to go back now. You made it. Sorry, we just played the game. And, you know, you can share information, as we said. So I'm going to give a kind of introduction to recommendations, and then we'll dive into the technology. So we've got two people, Alice and Barbara. And Alice says, I love my new iPhone 6. And it hadn't actually been announced when I first did this slide, so it's probably lost a bit of its impact. And Barbara says, me too. Alice then says, Alfresco on iOS is great, isn't it? So they've established kind of a rapport. And then Barbara comes back with a recommendation. So they've got this commonality, you get a recommendation. So let's see what I did there. And that's the essence of kind of collaborative filtering, which is a machine learning technique. So to show it a different way, we've got users at the top. So, you know, Alice, Bob, and Chris. And Alice has expressed an interest in items 1, 2, and 3. And Bob comes along and says, oh, actually, I like 4 and 5. So with Chris, when he kind of likes item 1 and item 2, you know, the natural recommendation is to say A and C have, you know, similar tastes. So because A is also like 3, we can recommend item 3 to Chris. And that's kind of user similarity recommendations in a nutshell. So there, obviously, most people are familiar with the e-commerce applications of this with sites like Amazon. And this kind of association is a Boolean preference because we haven't got any strength, which is where 5 stars come in. Because generally with likes, there's often no dislike. You know, it's either there or it's not, which is why it's Boolean. But 5 stars gives a level of preference. And the back-end Alfresco rating scheme, you know, supports the 5-star rating, but it's not exposed in share, other than through a Jeff Potts Metaverse and 5-star add-on, which he did for Alfresco 3334. And we're going to use that as the basis of the code we'll see rather than reinventing the wheel. So in terms of an overview, we've got kind of the share side of the 5-star ratings add-on, and then at the back end there's a rating WebScript that'll talk to, a rating service, and then essentially the database at the back end. And this is all driven by a rateable aspect. So I'm just going to jump into how readable is that at the back. Okay, so this is a standard out-of-the-box 4.2 enterprise other than the addition of the 5-star ratings. And this is one of the standard sites and users that are provided. So if I pedal a bit faster on my virtual machine, we can jump into a site, and then if I hop into a project library, no. And if we look at the aspects, we can see this one's already rateable. And then down in the properties, we have a star widget. So I can just click on that and it will re-rate it. Because I obviously chose a bit of content that stupidly I had already rated earlier. Let's see if I can find a different one. I've also rated that one as well. But again, I can change my rating, and there you can see it's now showing that the average is a partial star. If I scroll that up a bit, so Heiko can see a bit easier. So, as I said, 5 stars gives you a level of preference, and that's where an open source framework back in 2006 called Taste came from. You know, because people are showing their taste for content or items. But of course, there's an elephant in the room, and hopefully everyone recognises that icon. It's from the Hadoop project, which was named after a stuffed toy elephant. So Hadoop started life as a sub-project within Lucene and part of the Nutch sub-project. So Doug Cutting had read Yahoo's paper on MapReduce, and he was building a crawler to index the web into Lucene. And as part of that, he built a distributed file system. So this gave, you know, on top of that distributed file system, he also implemented Hadoop MapReduce. But that's slightly beyond the scope of this session. However, it's interesting background because the machine learning library we're going to look at is called Mahout, and that comes from a Hindi word for elephant rider, hence the logo. However, the Mahout project pulled in the Taste open source framework, and that's the bit we're going to be looking at. They also created distributed machine learning algorithms on top of Hadoop, but that's now legacy because they're moving over to Apache Spark and more of a streaming model. So Mahout does 3 areas of machine learning. So recommendations, using things like user or item similarity, clustering, which is the ability to group similar documents, and then classification, where based on a set of training data, it can classify documents, how they match to other documents. But we're going to be looking at recommendations. So the first thing we need to be able to do is support those recommendations with data. And the standard JDBC-based data model implementation within Mahout uses a composite primary key. So it has the item ID and the user ID. And then we have a float value that gives the level of preference. And then there's a timestamp, so it can be more efficient when reloading portions of the data model. Within Alfresco, obviously, we have to map from a node reference to get the item ID. So we can do that using the node service and just reusing the database ID. For the user, there's an extra step involved because we actually have to pull the authority node reference from the user information before we do exactly the same thing and get their DB ID. So a fuller overview is kind of fleshing out this picture. So we've still got exactly the same 5-star ratings add-on, but we're taking the metadata out, and obviously it's being pushed into a separate database table to make it more efficient for Mahout. And then pulling it out through the Mahout data model, through the recommender, and then up to a recommendations dashlet, which in action looks something a bit like that. Obviously, a bit of CSS love wouldn't go amiss. So if we go back to the demo, and then we'll walk through the theory behind what's actually going on. So if I go back to Alice's home page and add a dashlet, and now what's actually going to happen here is because of her tastes, she doesn't actually have any matches at the moment because there's not many users and not much content. So there's this sparse data problem. However, if I swap to admin, we can see that the administrator's been recommended content. And assuming my session hasn't timed out, then I can go and see I can see this content, I can rate it, and then effectively I can interact with the content that's being sent to me. So what's happening behind the scenes here? There are four kind of things that go to making recommendations. So we've already seen the data model and the fact that we're pulling this out of the database. We then have two other things, the user similarity and the user neighborhood, that are used to create by the recommender, which is the funnel, to create recommendations. The user neighborhood is kind of a way of grouping users together. So based on a given user, so in this case Alice, we could say we'll take the nearest n. So if you imagine them in a kind of a vector space, we could say, okay, the nearest 100 users, and that's a neighborhood, and that gives a fixed size. But that's not necessarily that accurate. Whereas with the threshold one, we can say they need to be have a certain similarity rating to Alice. So in this case, Chris falls inside it from the earlier example, but Bob's outside it because we saw where their preferences were aligned. And in terms of that similarity, as I said, it's a vector space. So you can, it's a multi-dimensional space, and you can take, for each individual item, you can draw out along a line how far their preference is for that item, and then you can group them together. And then one way of doing that is to use measurable Euclidean distance. And again, with sparse data, you need a certain amount before you actually get recommendations out of a system. So now to look at some of the code behind it. So this is just standard Mahout API to construct the data model. You tell it, you pass in a data source, you give it a table name. If you're not using, you don't have to necessarily use those if you're using the default preference table, but you can tell it where to pick up all its items it needs, wrap it in a data model, and then you can tell it that it's a reloadable data model. So then we have to construct a recommender. And as we saw from that funnel, it needs a few bits of information first. So we're telling it to use Euclidean distance, so that's the measurable distance. And we're telling it the data model to use. We then specify the neighborhood, and in this case, a threshold neighborhood. And the first value means that they have to be sort of at least 50% similar. Obviously, normally you'd tune that value based on the amount of points of preference you have in the system. And then we can construct the recommender itself. So in this case, we're using a generic user-based recommender because we're using user similarity. And you pass in the model, the neighborhood, and the similarity. And this is wrapped within a recommender builder. And then to get the recommendations, you just simply pass in a user ID, which tells it its kind of starting point within that vector space and how many recommendations you want to get back. And that's what drove that dashlet. But it doesn't just stop there. What makes a good recommendation? So for the admin, he was recommended this grass picture and a green energy logo. And how do the validity of those recommendations change over time? Machine learning systems often require retraining or sort of algorithm tuning to retain their effectiveness. And within Mahout, there's actually support for that. So the first thing we can do is score its recommendations. And to do that, we use the recommender builder that wraps that code we saw earlier. And then we can use some different evaluators to come up with how good our recommendations are. So in this case, we're using an average absolute difference recommender evaluation. And what that does is works out a recommended score, and then based on a portion of training data, it evaluates how far distance-wise it was from what the user actually chose. So to do that, we pass in the model, and in this case, we're using 70% of the data for it to create recommendations on, and the other 30% is held back for scoring as training data. Or to show it a different way, it will split that data set because we told it to, in this case, the last one is a 1, which means to use all of the data. If you've got a data set of hundreds of thousands or millions or tens of millions of points, then you wouldn't want to do it on all of it because you might be waiting a long time. But in this case, we can split it, create the recommendations, compare it against the training data, and then score the differences. Which is all very well and good, but how do you see that as an administrator? So we've got an evaluation WebScript, and in this case we've got a score of 0.511. The lower the distance away from your actual score you give something is better. This is from the Grails Mahout plugin, and they've actually built in something that takes all the different permutations. So that's not going to be very legible at the back. But in essence, you can try lots of different permutations of how similar they are on a fixed size neighbourhood. So that's where you've got the nearest n, or on a threshold-based neighbourhood, and then try all the different combinations of weighted and unweighted similarity algorithms. And in this case, it turns out that a threshold-based neighbourhood, so based on the similarness of users, and using a Euclidean distance, so that measurable distance between them in the vector space, produces a low score of 0.15 difference between what it computed someone would like and their actual score. But there are other information retrieval statistics that are useful. And again, Mahout has support for these. So if you imagine that we've got this big set of all the documents, and then we've got a set of results, which is this orange ring, and the relevant results are the yellow piece. So I'm going to have a drink. My mouth's a bit dry. So precision is the proportion of top results that are relevant, and recall is the proportion of all relevant results that are included in the top results. So you typically measure these at a certain number of results, so precision at 3, meaning the top 3 results. And then the fallout is the proportion of non-relevant documents that are retrieved out of all non-relevant documents available. So that's kind of this bit in here. And again, Mahout's got information retrieval statistics built in, so we can take this recommender builder again, create a different recommender evaluator. So this one's using the information retrieval statistics. We set that up and we pass it in the builder, so it gets the recommender. We pass it in the model. We tell it that the 3 is the number, the point of results we're comparing. In this case, we're going to use all of the content available, and we're going to all of the scores available, and then we're going to let it choose a threshold boundary. There are a couple of nulls that are being passed in there. One of them is a data model builder, which isn't relevant as we're passing in the model itself. And then the second null is a rescorer. So you can write your own algorithms to rescore things if you see the world differently. And there are a few more statistics available, things like F-score, but for simplicity we'll just focus on those ones. And then, again, that kind of fleshes out the ... that we saw earlier in that WebScript. So this is an admin-only WebScript, and you can look at how your recommendations are performing. So with precision and recall, high is better, and with score and fallout, low is better. Which brings me on to the final part of the demo. So if I hit that, it changed them. So I hit that admin WebScript based on the kind of extra activity. As I refreshed it, it changed. So you can see that we've got an average score of 0.542. So that means that if a user it scores it 3 or 4, then maybe the recommendation was saying it was 3.5. Or if a user scored it 5, then it was saying it might be a 4.5. And in terms of precision, because this is based on precision at 3, 2 out of 3 were relevant. And there's a kind of a low amount of fallout. So to recap, if you take 5 stars and then you add in Mahout, and you get recommendations out at the end. Any questions? Oh. Go on, Toon.
Instead of letting the user rate the document with a 5-star rating system, could he express interest in a document by, for example, he checked out a document for edit offline, for example?
So, I mean, obviously, moving forwards with the new analytics capability that's coming into Alfresco, there are a lot more events being surfaced. So you could start to take some of those more interesting aspects of behaviour rather than explicit preferences, but then you'd have to you'd have to write your own similarity implementations and work out your own recommenders to how those things correlate and how you analyse them. But yes, that's kind of makes it more interesting if you start to bring in the behavioural aspect rather than just kind of explicit preferences. Fran?
How does it scale? Have you done some performance testing and stuff? Because, you know, for 5-6 recommendations, it works fine, but if I don't recall badly, the database modeler cached everything in memory.
Yeah.
So when we were doing similar tests, I mean, it consumes all the Java heap, and that's why we moved it to Abul. Have you done some performance testing?
So, I mean, this was kind of a simplistic one to introduce it to an audience, but yeah, if you're talking about larger volumes, then yeah, you can't use the taste portion of the framework. You have to look at the other elements for the distributed recommendations from Mahout. Any other questions?
All the calculations, you do it on the fly, or do you have a background job that performs all the operations?
So in that case, it was doing it on the fly. Yeah, so it's got the model in memory, and it's just doing them on the fly. But yes, you would, for a larger, higher activity system, you would probably batch them. So I need to put up the last slide, which gives the kind of the image credits. There's a set of additional links. And I need to thank Abul, Clara and Giuseppe, who did some of the work for that. You get a picture of that, Abul, Giuseppe even. Oh. And somehow I managed to gallop through that a lot quicker than I did in San Francisco. So if there's no further questions, then I'll finish. Thank you.